Hello, hello. It's Wednesday, my crew. Hey, Magoo. In first, as usual. Good job. Hey, Rhiannon. How's it going? I saw you on, I saw you on Sorcery's stream earlier today, maybe? Hey, Nyx. Oh no, your mod is broken. Hey, Sapphire. Your mod is broken, Nyx, when people don't apply matrix transformations properly onto the models. So now you're doing matrix transformations to fix it? Yeah, writing your stuff in a way that you're depending that other people's stuff is also coherently made is tough. That can be tough. I'm gonna have to include a lot of stuff to help people with this. Hey, Interstelly, an FTL-like? Yes, FTL Fast and Light. I brought this page up because I thought you were gonna ask me what an FTL-like is, but it sounds like you know. But yes, we're working on a Star Trek kind of, I'd say scale-wise, it's somewhere between Firefly and Star Trek in terms of the vibe we're going for. Like smaller to medium-sized ships. But I do want a certain thing. And we're going for it with a kind of isometric 2D look. We'll dig into the work here. But how's it going? Interstelly, I like your name. It just clicked for me. Hey, Nanigans. Sorcery's your normal morning co-working stream. Sorcery's great. Clearly, you only watch C# Godot developers. I love seeing all the art being replaced. Hey, Nick's on the 10 stream streak. Yeah, we're working on the rendering for our little 3D kind of thing because we're building these ships in 3D, so they're stacked. So they're not going to be top-down 2D like in FTL, and it's not going to just be one deck. It's more vertical. So the game state, the game space is 3D, but the rendering is all isometric 2D. So we've tried a few different approaches for the rendering. We did tile map layers for a long time. We're trying a new approach where we manage our own canvas items that we draw to. It's good. I worked on it last night. It is working. The only downside from what I tried last night, and I tried to multi-thread it to see if there was an issue with like getting the data there quickly enough. Doesn't seem to be. There seems to be just a cost to rendering. We are CPU bound on the render side is the way that a person would describe this. So I can kind of show you. Don't mind the debug texture we're using for the blocks. So I can render out a block here. We're using like a hammer editor style, little magenta debug texture. So I can build out these 3D rooms and stuff, but we start to run into a performance issue. You haven't really seen it yet. It only happens when we are rendering a ridiculous number of things. Like if I completely fill this space, you can see it starts to slow down a little bit. And if I open the profiler, you can kind of see, you'll watch the bar go burr on the CPU side. How do I show the two next to each other? Well, this is different than what I was looking at before. I don't actually know how to use their profiler very well. The visual profiler? That's what I was using. Well, our physics frame time isn't great. Maybe there is something going on there. More importantly, if you look at our visual profiler, you see this big bar up here. I don't want to fit to frame. Show me what's actually happening. Yeah, you'll see the rendering is pretty beefy. It's all in rendering the canvas items. So what's happening here is we are queue redrawing every single canvas item, every single frame. And that's what we want to not do. So the thing that I think the biggest opportunity for optimization is to just reduce the number of queue redraws, which you only need to queue redraw when the draws change. Otherwise, if the draws don't change, you don't need to queue redraw, and the thing will keep being drawn to the screen, but you don't have to pay that cost of pushing everything to the GPU. So that's, I think, where we're stuck. I'm kind of curious about where all that time... We have stuff happening on background threads, so maybe that's affecting this. Draw param setter seems to be doing a lot. I need to use our profiler more. Interstelly, interesting. All you know about models is just using Blender. Making 3D models and putting them from a top-down view. You could do it. You could do it. We're doing pixel art. I still want to do pixel art. I don't really have a 3D art workflow. I'm not a 3D artist. Yeah, so we're going over on frame time. I want you to tell me more. I want you to tell me more about these calls. Well, this doesn't account for all the frame time. I swear we're spending most of it rendering. Let's see. Okay, no, script functions. Draw is taking 90. That's huge. So yeah, it's all these calls to draw. Setting the params is nothing. Getting the texture atlas is kind of slow, but that's a side effect of the draw calls. So yeah, if we can reduce the number of draw calls, we will solve most of this, I think. It's a little concerning we're spending this much time in the physics step. That's probably because I think I know what's happening. Maybe? Well, maybe I don't. There's definitely some more optimizations we can be making on the other side too. But this is what we want to work on. Interstelly. If you're having a problem rendering a ton of small things, what if you get the assets and merge them into one asset for large-scale based things? That will not work. And that will not work because of a cutaway system we have. So, or I could build like a room, right? So let's say I'm here and I build a room. I can build a room of a ship. And I seal it. You know, it's a sealed compartment of the ship, right? Then we have a problem. I need to be able to see inside this room. The way we deal with that is with a cutaway system that peels blocks away, but it also means we're changing what we're drawing all the time. So we can't bake it, which is essentially what you're suggesting. Just to bake all the assets together into bigger pre-made things. We're actually heavily leaning into this cutaway thing. Which actually makes me think eventually our canvas items might be per compartment rather than per Z index. I'm gonna catch up on chat in a minute here. Just kind of thinking about stuff and realizing the music is whack. Mischievous Sprites. That was a very appropriate song to be playing. But yeah, right now we do it like this. Everyone loves this diagram. We do it by Manhattan distance. So we do Z index to camera basically, or Z distance to camera. Is currently how we're splitting up these layers, but I could see a world where we do it by compartment instead. But we're not gonna worry about that. worry about something else. Shenanigans. If you're not doing it already, you should be able to speed it up quite a bit by only drawing the outer shell. Yeah. Only drawing the outer shell and or, you know, not queuing a redraw if the draw parameters don't change. So we'll probably need to keep a copy of the draw parameters and compare them. Or something. Even just checking to see that it's empty should be good. Because, yeah, it's all these draw calls. And it's not draw calls like the thing is on the screen. It's draw call with an underscore. It's like the draw is different now and it needs to recalculate. Because CanvasItem is actually really good and has really good performance by default because it does not automatically queue a redraw. Like once you've drawn something to a CanvasItem, it's like really cheap to just move it around. So if you have a lot of static sprites, it's pretty cheap to have a bunch of them physically moving around. Our trick is that we're redrawing stuff all the time. So we just need to, yeah, do some occlusion culling and do some like hashing or some checking to make sure that the draw parameters are the same or not the same before we push them. Rhiannon, you were going to ask if that was because there's no culling. Yeah, the culling should help. Culling should help. Not just the culling that we do in terms of the cutaway, quote unquote, but also, yeah, like a traditional occlusion culling kind of deal. Rimas, how's it going? Nix, you like that anti-spaghetti nuclear pasta kind of looking pink and... Yeah, the pink texture is funny. Nanigan, you can then go back and draw the hidden blocks if you need them for cutaway purposes after the outer shell is done, asynchronously on future frames as you have frame time to spare. Maybe. Yeah, that's the other thing too, is even if one of the CanvasItems has technically changed, if we're not looking at it, we don't need to draw it again. So that's another reason why I'm tempted to do compartment-based drawing. Because right now, we're actually grouping all of our CanvasItem draw parameters by z-index. So when we send them over, we send a big block of these parameters, and we send them all for the same z-index. But we don't actually need to do that. We could actually include many different z-index many different z-index tiles, and they would draw in the correct order because we sort them. So yeah, I think in the future we are going to try a compartmental thing, and then we can focus on only drawing on compartments that can be seen in addition to everything else we could be doing. So yeah, I think this is an optimizable solution. And even though the performance with tile map layer is basically identical, which is not surprising, it's not like Godot is going to add a bunch of drawing issues to a tile map layer over just a CanvasItem draw. It's better because it lets us interleave moving characters that would have been hard to include in the tile map itself. We can draw them into the scene at the correct like Y sort and everything. So yeah, I'm looking for a point where we're really just drawing the active compartment and a couple nearby compartments, and I'm hoping that'll be a lot more performant. All right, take it easy, Mr. Magoo. Thanks for hanging out. Appreciate you. And against one complex case I would need to account for if I did compartment-based drawing is if you have, say, two C-shaped rooms that couple each other. Neither one would be fully in front. Yeah, I mean, that's an argument against doing it compartment way. We could find a way around that by having, like, quote-unquote sub-compartments if we can detect that there's that kind of a conflict. Because, yeah, we'll have stuff with that. Because not only is the C compartment that you've described a problem, but think about the compartment within a compartment. like an O ring. Like if there's a big circular outer room and then there's a smaller room inside, same problem. So yeah, we would probably need to do some kind of, we'd probably need to break it up into rectangular subcompartments and render to those. But yeah, let's try the z-index stuff first. It might be good enough where we don't care, right? I'm just thinking a little ahead. Because we could totally mix them and it would mostly work. But we're not going to start out that way. So what we're going to start out doing, now that we're doing our drawing, we're doing it index by index. Hide this. I'm not using that right now. So we're doing it index by index. What we need to do is some kind of initial check to see if there's a change. Which is fine because the parameters don't take up a lot of space, so it should be pretty easy to check them. We have a hash code process here. Will this work? It should. Interstelly, would transparency help? Oh, no apologies. Every suggestion is a good suggestion. Yes, you don't have context to what we've done and what we've tried. I don't think no suggestion is bad. It might be bad for us. And that's just something we'll talk about. So yeah, please, I appreciate the engagement. Transparency is a complicating factor. Transparency makes it harder because normally we can tell if a block is fully obscuring the block behind it. But if that block is transparent, that's a little tough. So transparency is probably something that's going to be handled. Probably getting drawn onto the same layer over everything else. So maybe as like a second pass or something on. Well, it can't be a second pass, but we'll need to handle it when we're sorting. Honestly, I'll probably take away the version field of the parameter and add like a transparent bool or something. We also record the modulate, so we could just check to see if the modulate's other than 1. I guess that would be an easy thing to do. Have that be like a fallback for the sorting algorithm for it. Where it's like, if it's the same z-index, sort based on the y-sort. And then if it's the same y-sort, sort based on the modulate. That'd work. Yeah, what we're going to do... So the biggest opportunity for improvement here is twofold. One is to... Well, threefold. One is to turn the cutaway system back on. One is to do some kind of occlusion culling. And another is to check to see if we can avoid the Q redraw call. So I probably want to store a copy of this for comparisons. Maybe I don't need to do the copy. Can I like... Here's a question. He says, not asking a question. Can I say something like draw calls dot get hash code or something? So can I get a hash for each list? And we can just compare those. River on 7, good Wednesday here. So yeah, I could probably just keep track of the hash codes for each layer. It's probably fine. Thanks for the hydrate and the stretch, Sapphire. Got some kind of crick in my neck or something. It is I'm not having a good time with it. My posture is really bad. Try to fix that. I was tempted to have a separate like posture check, but I feel like that's implied in the stretch. Tomorrow's your last day out from work. You're gonna do work from home for a week. Nice. Wow, time flies, huh? Interstellar, you when you see magic words on a screen that you don't know, don't worry about it. I think there's something about looking at someone else's code. Even when you know programming, looking at someone else's code is like reading an alien language sometimes. All right, so we'll sort the list because that will certainly impact the hashing. Oh, hold on a second. If I call hash code on a list, it gives me the hash code based on the object's memory reference, not the content of the list. I need something else. I could just iterate it. Oh, Onizumi Kawari, raiding with a party of 8. Raid alert. Hide the code. How's it going? Stand down on red alert here. How was the stream? How are you doing? Hey, Eladia. What is up? Don't be so embarrassed about your code. I said it one time and now it's just like a funny thing to me. I think it's funny to hide the code. But hey, how's it going, Raiders? This is Digital Iliad. We're working on an isometric FTL-like game, which basically means we're working on a kind of little starship management style game in the vein of like FTL faster than light. See, Rihanna Journey likes the emergency hide the code. The code is not good, but it's doing something. It's doing its job. Onizumi, you are suffering greatly through Godot's 2D skeletal animation system. Oh, really? That sounds unfortunate. I feel like they've made some changes to that in 4.6, right? I feel like I was reading something about that when I was reading the release. It's something about their skeletons. I don't do a lot of animation. The only animation work I do is usually like sprite sheets, which you know, speaking of like animation in games, let's pour one out for Adobe Animate, I guess. Thank you for the raid. You gotta run, no worries. You're gonna hang. I appreciate that. Onizumi, the skeleton's bones are fine. It's the vertex setup and the weight painting is the most atrocious thing you've ever seen. Ooh. Yeah, I'm the kind of person that whenever I see like a configuration by hand thing in like the Godot editor or any game engine editor, I'm always like, do I have to do this? Do I have to do this myself? I so prefer to do everything from code. But again, I don't actually do any, like, I don't do much art. So the art I do is very simple and I don't have to work with that. But it sounds rough. But I'm sure you're powering through it. Interstelly, there's a saying you once heard, if it looks stupid but works, it ain't stupid. That should be plastered up in front of me. Should write that on my forehead. Code that functions and runs performantly is at least a B+ in your book. Okay. Well structured for maintainability is S tier. Well, we aren't there. We aren't there. Maybe someday. I do want to head into the direction where we've created packages for more of our high level stuff. So I actually treat the code there a little more seriously and a little more modularly, because we're already getting dividends on the modularity of our code. Like, we were able to swap in a new rendering process with 0 changes to the rest of the code outside of the rendering. So pretty neat. That's probably the biggest thing for modularity, for maintenance, right? It's modularity. Onizumi, there's a plugin that solves like 90% of your issues. You're baffled it's not the default functionality engine. Oh, that's crazy. That's the power of Godot, I guess. That's the beauty of it. You're impressed by how fast we got the new renderer running? Yeah, it only took like a week or so. It helps that it was basically the same thing we were already doing, just through a different process, but... Interstelly, code feels like conveyors in a factory game. The term spaghetti code translates well to those games. Oh, yeah. People have compared, like, Factorio to a lot of things, like system on a chip design, programming, like... Hey, I am not going to pronounce this name correctly, but I see you. I'm gonna make an effort. Hey, Sopeso Meso. That's quite a name. Welcome in. Thank you. Nix, wait, we got something working? Maybe you should change your 5.12 prediction. I wouldn't get ahead of yourself. Because as we were discussing earlier, clearly the things we need to do... That should not be hard to pronounce. Hiso, peso, meso. Is it 3 2-syllable blocks? You're talking to a gringo over here. Does not know how to pronounce anything other than... Okay. Appreciate you. All right, so we can't just hash code the list. We have to hash code the... I mean, we could just iterate. Does a span have that? Block tags dot get hash code. Is a hash code for a span the same thing? Will it just hash the oh my god. Will it just hash like the pointer or something? What happens there? Okay, it's not supported. That is not a supported. I want to hash by value. Yeah, we're not doing a string. So I can make a new hash code struct. Let's do that. Oh, thank you for asking the right questions, Rand and Journey. What game project are you working on, Onozumi? You're still hanging out here. Quote unquote, is this a game yet? It's a bit of a social experiment. You started with just a button that makes a number go up and a leaderboard and everything. After that is decided by the submissions of the people that top the leaderboard. Oh yeah. You're doing it's not Twitch makes a game, but it's like it sounds like the most fun. It's designed by a leaderboard. Sounds good. That's great. Yeah, how has that generally been going for you? I feel like it's like herding cats and or, you know, Godot contributors. So I think the right thing to do here then, we sort it. We can say here, let's do it in this loop. This seems like the right way to do it. We'll do it in this second loop, and that's where we'll decide whether or not to pack the CanvasItem draw params. I might even call it update or something like that. Relay, who knows? Say something. All right, so what we're going to do is we'll have a hash code. I can have a T hash code. Mine's the hash code of sequences of T values into a single hash code. Hash codes returned by the combine read-only span T method are only guaranteed to be repeatable for the current execution setting, just like with the available blah, 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 blah. That's fine. We don't need this to be consistent across multiple runs. Let's do this one. The hash code T, CanvasItem draw params. We use the community helper version of hash code, I think. Here we'll say for each draw call, draw params. Should we just say for each draw? No. Yeah. You say for each draw call in draw calls I. Say hash code. Hey, Helkios. How's it going? Howdy. Howdy doody. Onizumi, the development was very fast-paced in the beginning. Then you had to pause for a couple months, and you were picking it back up. It's great. You went from some OSU-style clicking game to WASD-controlled gameplay, and you're currently working on boss animations. Okay, yeah, this seems like it's going. That's very cool. Can't imagine where you're gonna end up. Good, good. You're just deving and watching dev streams. Nice, nice. Yeah, welcome in. Hopefully this is a good, nice spot for you. I'm gonna say hashcode.add. Draw call. All right, so why does add not work? This ref hashcode read only span T. Oh, maybe I don't understand how this one works. All right. It's a content hash from the input read only. Oh, does this do this once? So this will go through the span. Oh, neat. So I just say dot combine. So I don't need to add. I don't need to go through and add everything. Okay, yeah, let's try this. That's better than looping, I guess. Let's just say combine. Oh, do I pass it in the parameter here when I construct? No. Let's say draw calls I dot as read only. What's going on here? System collections object model dot read only collection. No, I don't want as read only like that. I want it as span. And then now what's your problem? Oh, this isn't static. I see. Hash code. CanvasItem params dot combine. Neat. Or is this an int? We get an int back. There we go. All right, nice. That saves us a lot of time. You're gonna leave? No worries. Thank you. Take it easy. Take it easy. All right, all right. So we're getting a hash code from our list of draw calls once we've sorted it. And then all we really want to do is we want to say if we can say if hash code is the same as hash codes I, we'll continue. So we'll only do this, and then what we should do is we should say hash codes I equals hash code. Are you getting the hashes to check what needs to be updated? Yeah, that's the idea. That's the idea, is that we'll quickly hash the list of draw calls for the given Z level. And if it hasn't changed, then forget it, you know? That should reduce the number of queue redraws very quickly. Assuming it works. I realize I could do the sort and then this part. I don't really need to do all the sorts ahead of time like this. But there might be an opportunity to thread this part or something. I mean, there might be an opportunity to thread each individual list's check here. We could honestly go through each draw calls. We should check to see if the list is empty. Actually, here, let's do this. Let's do this. Although if the list is empty, no, we still need to hash it because the list might not have been empty last time. We could still probably save some work there, but let's not get bogged down. I'm almost certain this is going to crash or do something. So I'd rather just figure that out. Okay, so far no crash. All right, let's see if we still see the horrible performance if we just make a big block. It'll perform horribly until we've made it, and then my hope is that it will be stable. Okay, no change. No change. There is no change. Still very poor performance. All right. I'm still not sure if this combine does what I think it does. This is a community toolkit high performance helper for a type. It takes a span of that type, so I assume it's doing what I think it does. But you know, that's a dangerous assumption. So we'll double check. Okay, that says nothing. It says nothing for us. Maybe there's some more info here about the individual things here. Yeah, it seems like it's hashing based on the content. That must be what it's doing. I sort of believe. So basically, it's the loading screen stuff that's the optimization problem. Not really. The optimization problem... Hey, Matthew Sparks, how's it going? The optimization problem is that we are updating the things that we're drawing. We're queuing a redraw of a canvas item, and when that happens, it needs to send a bunch of stuff over to the GPU, and that is expensive, and that is why we are CPU bound, it appears. And so what we're trying to do is just reduce, we're trying to assure the system that some stuff does not need to be updated. The first pass of this is to just do it based on whether the list of the draw call parameters hasn't changed. I'm going to set a counter to see how many of these we're changing at a time. YouTube is active today. I know. Tell me about it. How's it going, y'all? Okay, so it looks like we're just changing a couple. We should be changing 3 at a time when we do this. I don't know why it says 2. It makes me think I'm off by 1 with my count. It says 2 or 1, which is suspicious. Oh well, let's see. Let's see if this is doing it. Hey, LSDev. Yeah, wow. YouTube's popping off today. All right, so if we do this... Yeah, so it's updating like a few dozen layers at once, and now it should be back to... Oh, God. There's some kind of camera thing where if I move the camera too quickly after drawing something that like lags us out, I think it's like accumulating input or something, and it just... The camera goes nuts. I want to figure out where the slowdown is here. Yeah, the camera is just... I'm going to not move the camera. So that is causing a lot. Here, I'll move the camera first. Then I'll do it. Okay, 38, 38, 38. Why is it only ever counting up to 38? Is that... There's like 100-something layers here. I guess 38's the only layers we're using. Okay, now it's saying... 6, 5, 5, 6, 7, 8, 4. Okay, so this is doing what we want it to do. We're updating way fewer layers. We're usually just it looks like we're just updating the 3 layers that the block came from. Or I guess the 1 layer. Yeah, wait, why is it 6 to 7? That does seem like a lot. Why is it 6 every time? Weird. It's still less, but it's not like a lot less. What's the profiler say? Okay, it's better. What's the rendering like? The script functions. Okay, yeah, we're paying like a millisecond in the draw. Okay, so the draw is no longer the thing holding us up. We're being held up by something else. Okay, let's go to the visual profiler. Render is just still so expensive, but maybe that's just what this takes. How long until we start just doing this in a shader? Remember to like the stream. Thank you, Interstelly. I appreciate that. Yeah, like, subscribe. We have a Discord. If you're interested in sharing your work or following along with our work. How's everyone doing? All the shader programming? Yeah, LSDev, we're trying something else. We're trying to just do our draw calls directly to CanvasItem instead of messing around with tile map layers. And like, it works, but we're like incredibly CPU bound. However, it is trying to draw tiles for this entire... It's drawing this full solid block. So the next thing to do is, now that we're doing the hashing thing, which came together crazy quickly, What we want to do now is we want to do like an occlusion culling. Kind of like a cutaway kind of deal. Of like a, we don't need to render this block, so don't even bother. So we need to turn that back on. My only real question is, do we want to do it? Because I bet that would get us, that would reduce our rendering overhead by, I think, like tenfold. So let's see if that's true. I would love for that to be true. I'm a little concerned by how much time we spend in physics time. I think I need to thread out some of the physics time stuff. Because I think it's affecting our responsiveness. Because if it takes us a couple frames to decide what to do, that's fine, as long as the visual update is happening immediately. Random Journey, you haven't done much shader stuff. Would you be pushing it off to a compute shader or something? I don't know. Because again, the thing we're trying to solve for is having to send stuff to the GPU, and obviously there's times you have to do that. And I have done direct like GPU shader like rendering stuff before. It's really finicky, and that would require us to like really dig into the guts of like the rendering server to really understand what's going on. So I'm gonna avoid that. We're gonna keep that for like desperate times. I'm really concerned about this physics time. This is actually where our main problem is. I know this is a 0, but it's like the :O, and it just looks like a little face just being like Macaulay Culkining me in the debugger. Manigans, the thing that makes it harder to do in a shader, in your opinion, or even as a repeating texture, is that it's isometric dimetric. Yeah. That's what bit me when I tried to do this kind of thing in Unity, when I was doing kind of a voxel isometric thing. I really needed the like Y sorting and Z index stuff. I needed help. Physics? What physics? LSDev, the C# simulation layer is happening as part of a physics call, because I want it to be at a consistent frame rate. So it's on physics process. So we're not doing physics, but the gameplay simulation is happening on the physics process call, or as a result of the physics process call. So maybe we just need to reduce the tick rate, because it's taking us about 2 frames to do the work. And so maybe we just need to be giving that system a little more time. Nanigans, if it was on a typical XY plane, you feel like there's a few tricks you could do pretty easily just by repeating textures. The perspective, you think, complicates things. Yeah, it does. It wildly complicates things. Nix, me saying we don't need no reminded you of a song from Dylan Beattie's Enterprise Waterfall. It's a parody of Another Brick in the Wall. Okay, I'm down. I watched Enterprise. I watched a whack season 1 Star Trek TNG episode last night. It was this one where this guy like starts aging backwards. That show falls apart so quickly whenever anyone needs to do like a humanoid like aged prosthesis. They had like a man in his like mid-20s like dressed up as like an 80-year-old, and I'm like, this isn't Ian McDiarmid. We don't need to do this. I'm really excited about the next episode. I think I have queued up. I think I'm gonna watch that Thursday. I think I know what episode it is. Not as excited I am about this. This is our jam. This song is our jam. Farmlands, let's go. By Harris Heller. Physics is just a scheduling trick. It's Godot has process and physics process, and process is tied to the rendering update. And physics process is at a consistent, whatever you set it, 60, I think by default, 60 FPS. So yeah, it's our simulation tick. Honestly, we could probably lower that. Give it a little more time. Nanigans, have you tried just taking it out of the physics loop? You've seen a few other videos that have big performance gains doing that. You don't know Godot's specific physics loop implementation. Typically, if you exceed frame time consistently, you're going to essentially start a growing loop that will never catch up. Yes. Yes. So, I don't know. One could argue that this particular system could run on process. The way I've been approaching it is that if a system needs more time, I typically just put it in a background task, and then we just carry on until that task is done, and then we just execute whatever the resulting task is. I'm hesitant to have anything happen on the rendering process, the rendering rate, except for rendering. But yeah, I guess I don't necessarily need to have it be part of this monolithic, like, series of calls. Because it starts at our top-level state system, which it evaluates the state and then picks the systems or system groups that should run. But there's no real reason that we can't do it another way. We'll see. We'll see. What are we doing now? So right now, the way we're going to speed this up, because it's still slow. You know, worst case scenario is that, you know, we just constrain the buildable area more. Because right now that buildable area is 64 by 64 by 64, which is enormous. Like, here's a 64. Here's all. I don't even think the system will let me go this far. It slows down too much. But we're effectively using here, like, what? Like 4, maybe 8. We don't really use more than 16. More than 16 can't really be seen on screen at a time. So I think I'm optimizing for, like, a much crazier use case than we're going to typically see, especially early on. And certainly for lo-fi flyby, which is going to be smaller. But I would love for this to be performant. Because, yeah, you'll see as we start to increase this volumetrically, we just slow way down. And it would be interesting to see where the slowdown is. I think it's in the renderer, but maybe not. Maybe not, you know? Maybe not. That's why you profile everything. Profile everything. Like, let's do that again with the profiler running. Let's auto start the profiler. Can I sort by time? I wish this was better. Like, I wish I could sort this by more than just name, like, because I'm interested in these two numbers at the top, but I'm also interested in a number all the way down here. I guess I can maybe pre-select it, and it will show up on this graph. No, I can't pre-select because it's not here. I could say script functions here. Script functions. I'm interested in script functions. We're not interested in physics, which is like 90% of this list is just physics stuff. We're interested in physics time. We'll auto start it. All right, so I increase this. Physics time is 0 for some reason. There we go. All right, so is this gonna increase? So what's growing? It looks like it's script functions. Not, I see the pink line. You can't actually see it because it's like behind my head. But the thing that's growing was this cyan line, and the cyan line is frame time, but it's also, oh no, that's just frame time. So frame time is growing, but not physics time is not, which makes me think it's rendering. Let me add the script functions back. I want to see what the script functions do. So if I do this again, what's growing? Okay, it's not the script functions either. Yeah, it's just rendering. I think it's just pure rendering. Now this is our new rendering. Where's the rendering stuff getting measured? Oh, not here. It's getting measured in the... Okay, so it's showing this, but if I wanted to look at this more, this would be in the visual profiler, I think. So if we start monitoring this, yeah, it's here. Render viewport, render viewport, render canvas, render canvas items. Yeah, it's this canvas item. We're CPU bound for the canvas items, so we just need to reduce the amount of... We're spending all our time in the draw calls. Yeah, blue is not here except as just the overall frame time. But physics time is too high. Physics time is too high. So we need to deal with that as well. But let's see if we can deal with the rendering first. Can I monitor this? I could. I don't do enough debugging stuff and profiling in Godot.
Maximum warp.
Well, we're only getting a few draw calls and we're drawing a shit ton of stuff. So the instanced rendering seems to be working. At the end there, we had an FPS of 4, it looks like. Which is not great. Hey, No Joel, Maximum Warp. How's it going? All right, occlusion culling. Occlusion culling. So this is we want to just not have to worry about drawing things that don't need to be drawn. What's the easiest way to do that? Well, the easiest way to do that would be to take advantage of the fact of the cutaway system already. The canvas item drawing system should be doing this to an extent. Maybe we turned it off at one point or changed where this is happening. But I could have sworn. So when we do add canvas item draws, I don't think we're doing enough scrutinizing. So we do a simple check here for the mask. Here we say if block tags has block tags.cutaway. So here's where the language is going to get confusing. I consider cutaway something else. Like cutaway is like, don't show this because of something the player is doing. But that's maybe not that different than something like occlude. So maybe we should be doing... You know what's not happening is I don't think we're actually running the cutaway system as part of the block editor system group anymore. Block cutaway system.ready. Do we run it anywhere? We run the flood filling system. Hey, Jacob. I don't think we run the cutaway system after the flood filling system, which we should do. Did we do it down here? No, not really. We did something here. compartmentalize. We do some stuff with the room bounds. We get the cutaways for read-write. Why do we get the cutaway rooms? That's something else. Okay, so the easiest thing would be to just re-enable the cutaway system. I say easiest. I think the problem with the cutaway system is that it doesn't understand our new input model. How's it going? It's going good, Jacob. We're searching for gains. We're looking for some optimizations we can make. Cut away interior blocks by cursored rooms. Cut away exterior blocks by cursor coords. Yeah, this is something else. This is different than like an occlusion. I think I wanted a separate system for this part, but I thought the CanvasItem system, drawing system, did something like this. I thought we scrutinized things here. Like, here we go. So if we're doing the params X, we're drawing everything. Yeah, we are, but we're slow. We're slow in 2 counts. All right, how do I get rid of that count? That stupid debug that we were doing. This, don't need this. We're just too slow. The gameplay, the systems running here needs some time. I need to thread them out because they're slow. And then the rendering is actually looks okay in terms of performance. So maybe I should, better or worse than the tile map. The way I'd think about it now is that the worst case rendering of the tile map is not worse than the worst case rendering of the canvas items, which also means the canvas items is not better. So we're trying to improve upon the worst case scenario, which is Q redrawing every single canvas item every single frame. We've already made 1 gain on that because we're hashing the draw call list for an individual canvas item to see if it changed frame to frame. If it doesn't change, we're just not going to update it. That's reduced the number of draw calls, which helps. The next thing we're going to do is actually occlude, because what we're not doing is occlusion culling, which we need to do. So yeah, I think this has a higher... The performance floor is not better, but I think the performance ceiling will be better. And I think more importantly, this provides us a unified way of rendering. So we don't have to distinguish between the environment and characters interacting or moving through the environment. We can render them both the same way, which is not really true of tile map layer. So our current problem, and where we see, because this is all very responsive, but where we see the slowdown, right, is if we try to render a volume, like a whole volume. And this is not better. This is not better specifically because we're rendering every single face inside. So we've increased the complexity of the rendering cubically here, which we need to stop. And these are all solid. So I think we need a tag. I think we need to be able to tag a block for it to say that it's like opaque or something. And then we need to do something that's like the reverse of our raycast. We need to go from the surface down and just not render anything that's being occluded by an opaque surface, by like another opaque surface. So yeah, I think the occlusion culling would be pretty big. We doing shapes? Yeah, Mr. Cat. How's it going? We're drawing a cube, which is the problem. We don't really want to draw a cube. What we really want to draw is the cutout of the 3 visible faces of the cube, not every single tile in the volume of the cube, which is what we're currently doing. And I thought I had something in here to help us with this. So you just almost entirely rely on cutaway. You also... So you try to see if your neighbor is cutaway, and if it is, you don't. So I think the most obvious thing would be to just turn the cutaway system on and see if it helps. The cutaway system. The thing is, though, I don't think the cutaway system actually helps us with faces that cancel each other out. Like a face that can't be rendered because another block is in front of it. I don't think the cutaway system actually helps us with that. Maybe it does. I thought the tile drawing system helped us with that. So this is going by room. That's not really what we want. This operates on a block level, a block by block level, so it doesn't really do that per face thing. I think that is happening in here, but maybe because we don't have the cutaway data, we don't actually know this. You're not going to get me again with that one. Good try, though. Nanigans, you think cheaper than doing a raycast for each cell would be just check if cell x+1, y+1, z+1, or whatever your coordinate space is, has an opaque block in front of it? If so, skip it. Yeah, but that only works for one. When I say raycast, I mean like we could go backwards and we could describe what you're saying, but we would need to continue to go forward until we've reached the end, right? Because the block right in front of another block might not be opaque. It might be a block like 20 tiles in front of it that might be the opaque one. So there's two ways we could do that. We could either go forward and down from the camera and assume that a thing can't be seen, or we could go from the bottom up and actually fill it in for like every single tile. I don't know which one I want to do. I don't like setting a default value to anything, but having like maybe a visible flag on a block is maybe not a bad idea. Like have a visible tag. Like if a block isn't visible, then don't render it. And just assume, don't start blocks off with visible tags, and instead go down for each coordinate along the surface of the area. Go in and only tag the visible blocks and stop when you hit like an opaque face. We could do that. The problem is we're making the distinction here between faces and blocks, and that's actually a problem that I haven't decided how to tackle. If you're doing it at the time of drawing, can you not assume all blocks that you are dragging are the same opaqueness? Yes, I could probably assume that. But we don't really make a distinction for that in the sense of, well, I mean, that'll help with the overlays. That might help with the overlays. What we could do, and maybe this is your point, is maybe all the faces in a block would be the same in terms of opacity. Well, that's not really true. I'm thinking of stuff like this. I still haven't decided how I want to handle something like this. You know, these guys, things like this. This is not a great example because our blocks aren't this size anymore, but you could see it in maybe one of these smaller ones. Like, we do a lot of stuff per block, but this stuff we need to figure out. We need to concern ourselves with opacity per face. So like This face definitely blocks the same face behind it. But not this one. So we probably are going to run into a problem with that, but that's fine. Honestly, we'll probably have some pretty big gains if we can just eliminate these solid blocks. If we start by eliminating solid blocks, I think we'll be a long way to being in a happy spot. Should be able to tell if it's occluded or not just by checking the immediate neighbor, because if x plus 1 is not occluded, then x plus 2, x plus 3, etc. won't be. That might not be true if you're adding to a block space that already has stuff in it, though, right? You're saying, I mean, I guess that's good for evaluating something you're adding, but I'm thinking about how we evaluate stuff that, like, either changes of its own because it's animating, or... I get what you mean. I get what you mean. You want to drive it by the input. You want to, like... You want to detect that a change is happening and take advantage of the fact that we understand the mechanics of that change to decide whether the things that have changed need to be in one state or another. And that is a good way to approach it. I think my initial approach is going to be evaluate the block space as a whole after we've made any changes. But I think your approach is good. It's the same algorithm you're using to generate your voxel mesh faces. I might need to see like a diagram of what you're doing to understand what you're talking about. Why do those particular tiles remind you of Spin Dizzy or Marble Madness? They're very goofy. They're very goofy magenta. They're like dithered magenta tiles, which there are like debug tiles. They're meant to be kind of silly. But yeah, I'd be interested in your approach. Shenanigans. See how you're doing it. So what I can do, and what this system allows me to do... Oh, this should be able to tell us if there is another hall. At our neighbor. And if there is, return default. Okay, so we are doing a lot of per face occlusion culling already, which is concerning. If I'm reading this right, we're doing a lot of this already. So this says, like, if there's another hall on our layer that's one tile up from us, don't bother. But that's not quite good enough. That's not quite good enough for what we want. I think I do want to do some kind of additional occluding pass at the block level where we're trying to see what blocks we can just ignore. Here, you know, I'm going to take a slightly different approach. We're going to, it looks, according to Godot, the thing that's making our system unresponsive is actually the physics tick. It just appears visual. But what the profilers are telling me is that what we're actually paying for is in the physics tick. Let's see if that continues to be true here. Yeah, look at that. Physics process goes up to like ridiculous numbers. But process itself is actually fine. It's not great. It's definitely not great. but it's not atrocious. Like, our physics process is taking 40-something milliseconds right now. And our regular process is taking 16. So there's actually a scripting problem in the gameplay loop. This is where our hang-up is on the C# side, which makes me think I need to remove some process from the hot loop here and put it in its own little job and see what that looks like. So where do we think that is happening? Where do we think that is happening? Or, excuse me. What? Like, lost the ability to speak there for a second. Where do we think is the best place to introduce a background thread? I don't think the CanvasItem drawing system is the right place, but it might be. You know what? Do I have a profiler here? I feel like I must, right? I'm going to try to make the, like, bad scenario and then pause the program. Okay, that didn't work. Okay, pause. We don't have any tasks running. Okay. There does not seem to be any real performance profiling here. All right, let's throw some stuff into some tasks and see what's costing what. See where the time is going. Flood filling system is going into a task, which is good. That one we definitely want in a task. I think we want the sculpting system to be in a task too. I don't think we want the drawing system in a task. That I would like to be as hot, quote unquote, hot as possible. There's an argument to be made that if we push something onto the process step instead of the physics process step, it might be the CanvasItem drawing system. There's an argument to be made to put that on a parallel task. There's an argument. So it's weird that the top level system seems to be controlling most of this stuff. Here we go. Sync task. Game.blockSculptingSystem.run. I kind of want to put this in another task. I think that's where I think we're running into some issues there, maybe not. Shenanigans, even simpler than checking if a block is exposed or raycasting, at least for this case of drawing a large block of opaque tiles. You can just check if your coordinates are at the min of your bounds. You're certainly doing more complex checks after the fact to check if it's behind existing tiles, but it's at least a trivial check to barely. At the min of your bounds. I think you have a different coordinate system than I do. Because for me, the origin is at the far back. It's far back. It's as far back away from the camera as you can go. That's where the minimum point is. So you're saying like, yeah, I don't know. I can think of two ways to do it. I can think of doing it checking all the blocks at the surface and then just defaulting everything behind the surface blocks to be not visible. I can imagine doing that. Or I can imagine going back to front and actually bothering to check individuals. But the front to back check is good to me, because then you can say, okay, I've hit an opaque block. I know nothing behind this block can be seen, so just forget it. I'm tempted to do that. Will you learn more Godot if you just watch these streams? Yeah, not necessarily, as LS Dev says. I'm doing a lot of stuff outside of Godot. The max of your bounds? Yeah, okay. Okay. Interstelli, we do game. Well, one, we do have GDScript in this project, and I do interact with Godot nodes. Like, we've done something where we've split our simulation layer away from our rendering stuff for many reasons. I also do game jams. So we do over weekends, we do entire games implemented in Godot using GDScript. None of this fancy C# code base that I built up. So we definitely do just straight Godot development here, just like very straightforward. But our day-to-day project has kind of morphed into this weird thing. Yeah, Bernard, exactly. Exactly, no Jewel. Speaking of which, there's like an update I want to make to that. A couple of updates. I really need to do them because we got a jam in March and another jam in April. So if I don't, this is my month to like get my shit together before we're just doing back-to-back jams and like GDC and everything. All right, take it easy, Starship. Which jams? We'll do Down to Jam in March. I'm gonna definitely do Down to Jam in March, and I'm definitely gonna do Ludum Dare in April. I don't have anything else on the schedule after that, but I'll probably do a solo dev jam in the summer. I'm tempted to do the summer solo dev jam, and then I don't know what else we're gonna do. We'll probably do the Down to Jam in the fall. So I've got at least 4 jams this year I want to do, which is 1 more than last year, and we're trying to increase our jam count by 1 each year. We'll see when we tap out from that. This project is like a GDScript C# hybrid. Yeah, so the things like UI and rendering and stuff is still handled in Godot, and we have GDScripts for that. Like, here's the code that it's simple. It's simple, but yeah, I would say our day-to-day. Hard to say how applicable it would be to you, because this project has gotten kind of very specific, but you know, we're doing it in Godot. And if you like C#, we're doing a lot of C# too. We've been mostly programming. We've been spending almost all our time programming, but eventually we're going to get back to doing art and sound and things like that too, because I'm a solo dev, so anything in this game I made. You did a jam over the weekend. Now you need a break. What did you do? Was that a global game jam? If you did something, you should be posting that in the Discord. Jacob, you want to do a bunch also? You've been bit by the jam bug. Yeah, it seems like every time I do a jam, I get bit by the jam bug again. Yeah, you did global game jam. Nice, nice. Yeah, that one seemed to like a lot for me. All right, so what I want to do. So let me think about this in these terms. So there's something that I'm concerned about a little bit, and if we go through these layers, I think you can kind of see what I mean. So if you look at 0, if you look at the X face of 0, sorry for how bright this is. If you look at the X face of the 0 layer tile here, you'll notice that the tile is actually obscured by 3 different tiles. And then, not 3 different tiles, 3 different faces on 2 blocks. So if you look here, and then I load up tile layer 1, you'll see that that one segment, I would call it the -X, -Y corner, or half, whatever you want to call it. So one segment of this Y tile is obscuring it, and one half of this Z tile is obscuring it. So we could totally get very descriptive here, and we could actually handle this quite easy in a lot of cases. So this 0th tile face, so the X face of the 0th tile here could be obstructed by the Y or the Z faces of this tile 1X in front of it, or it could also be obstructed by the very same blocks in front of it there. Not on layer 3. So wait, hold on. It could also be obstructed by this part of this tile and this part of this tile. So there's a lot of obstructing that could happen. It's not just this where you have block 0 and then the 3rd layer block, which is the obvious one. So the easiest thing would be to check 3 layers in front to see if the face here is also being rendered. But otherwise, we got to check multiple things. We'd have to say, well, I guess it would be whatever the first thing is. Like, we could check this block. You know, I think this is a lot like our cursor priority situation, just in reverse, which is why I was thinking along those terms. So, like, when we are determining cursor priority, we will spiral like this. I think the easiest thing to do, if we don't go from the front back, if we do back to front, or we do from block forward, or whatever you want to call it, the easiest thing to do would be to do this kind of a spiral. To see about finding an opaque block. I need to decide how I want to handle this stuff. Whether I want to handle it per block or per face. There's a lot of cases in which per face will be better, but per block is easier and I think can capture a lot of stuff as well. You might get me. You might get me, the Mr. Cat. You might get me one day. But it is not this day. I'm actually very lucky. I don't really work on it because we don't do meshes here, because we're 2D. I actually don't say vertices very often. You'd have more luck with Nanigans. Or someone else who's actually meshifying their stuff, their blocks. Because yeah, I don't do anything on a vertex basis. It does make it harder. It's a challenge mode. It's challenge mode to get me to slip up on that. All right, I'm tempted to just put the sculpting system as a task. I'm gonna call it like the edit task or something. I don't know. Let's say private task. We're trying to figure out where all this time is going. We'll just say a very simple if sculpting task is completed. Then we'll just say task.factory.start new. We can put this there. Oh, if it's completed, what we need to do... So we actually can't get this bool out then. How are we going to do that? How am I going to get this local variable out of here? I actually don't know how to do that. I guess I could write to some memory. Mr. Cat, you're doing orcs and orc variations today? Nice, nice. Zug zug. Zug zug. Yo, Julie, you posted the game in Discord? Yeah. Work done. I have a hard time separating out some of the different, like I sometimes confuse my peasants with my orcs. Yes, my lord. Okay. Work done. Work. .3D renders to sprites is good. That's what people are doing. That's what people do now. That's kind of just all people do. You know what I'm going to say when the sculpting task is completed. Maybe we should just do a sync anyway. I don't really want to deal with this. Something need doing? Yeah, good. That's good. I can't sustain that voice for more than like the 1 or 2 word commands. I got the beast in my sights. Where you want me to go? Who you want me to kill? All right. So how am I going to do this? How do I want to do this? So when we finish our sculpting system run, what we normally do is if we need to sync the preview buffer changes, which is an out variable, which is only ever true for certain times. So I would need to rewrite the sculpting system slightly. Instead of having an out bool, it would need to need to return something like this. And we set it, and then way down here, we actually have not re-implemented a lot of this. We would say return sync buffer changes. So what we can do is when we are done, yeah, the voice lines, the Warcraft 3 voice lines are so iconic. So instead of pumping this out there, say variable sync preview buffer changes. It's false. Let's say bool, I guess. Okay, apparently it doesn't like that. So we'll run this. So if it's finished, we'll say sync preview buffer changes equals sculpting task dot result. Can I not get the result from the task? I thought that was an option. Do I need to say what kind of task it is? So it's a task, it returns a bool. I don't know how to do this. All right, let's look at task T, C sharp. All I want to do is know this little result from the task. My syntax sucks, though. I'm like so notoriously bad at syntax. What is a task T result? Like, oh, that's what we're looking at. It's a common way to do it. Call this task factory.start new, task factory T result.start new, sure. There's also task.run, and then all of this stuff, and then I return the thing. But if I... Oh, I see. This just needs to be like return false. We'll use the lambda. What's the problem with this? Okay, I don't need to do that part. All right. You've got to like declare the task immediately and like run an empty task or it'll never read as completed, which is annoying. I mean, I guess I could do it on ready. Okay, now I can get the result of the task. Great. And then this is where I throw this in here. This returns this value. All right, so when we finish the task, we get the buffer changes thing as the result of that task, and then we start the task up again. I just say task bool. Return statement is missing. Do I just say return this? Yeah. How is that as a lambda? Oh, that's simpler. Nice. I get so confused when trying to format my lambdas correctly. But I never did learn Greek. All right, so this task should carry on in the background. With the same effect that it had before. We can see if that's slowing us down. I don't think it is. I don't think the sculpting system is terribly complicated. I wouldn't be surprised if it's the CanvasItem drawing system that is slowing us down a lot. But we're going to find out, assuming we don't just crash everything immediately. I don't anticipate huge things. Here, this is not good. Getting a flicker, which is bad. Okay, this is worse. So it's definitely not this part that's causing the problem. It's good to know. Unfortunate that it's creating a flicker. I wonder what that's all about. I wonder how it could be doing that. We actually probably don't need it to work this way. We're going to revert just because I don't think that fixed anything. But I reserve the right to go back to doing it that way in the future. All right, so the likely culprit then is the very CanvasItem drawing system itself, which makes sense because it's doing a lot. Okay, no flickering. That was weird. So this is like fairly performant if we're only doing like this, which convinces me that like this is the problem, because this is like a little slower. Like you can tell it's not instant like 60 FPS, but it's way better than what happens when we fill in the space. So we're definitely paying a lot. Like, we're definitely not occluding like we could be. We're paying a lot for it, for rendering these. So we need something. But you know what we're going to try next is we're going to try the canvas item drawing. Which is here on the top level. We're going to store a task. Call it the draw task. We'll say if draw task dot is completed. And we'll say draw task draw task equals task dot factory dot start new. I'll just do this. Let's see if that buys us some time. We can flip this around. Let's see what this does for us. Hey, instantly responsive. Look at that. Who cares? Who cares about rendering efficiency? It's all about long-running background tasks. It was the system deciding everything that took the long time. Look at that. Hey, Marticus. Thanks for the hydrate, Nix. Yeah, it seems like this task takes like a couple frame, not a couple frames, it takes a couple of seconds to work, but it seems to not really be much of a problem. We'll have to see. I'm going to keep an eye on this. I mean, we do want to improve a lot of this. Part of our what we're going to do then is we're going to actually try to reduce the amount of thinking that the canvas item drawing system has to do. We want to eliminate things that it needs to think about because it's a performance bottleneck now. But yeah, we don't seem to pay very much for large things. That whatever's being drawn in white there is a little concerning. I don't know what that is. But yeah, it seems like we're not really paying for these large constructs anymore. And this is all stuff happening at edit time. This isn't like realistic performance for playtime. Playtime will be very different. But this is a good start. It's definitely much better than what we had. Now it's just a small delay. Yeah, exactly. I can live with a small delay. Small delays to the update is fine as long as the rendering. Yeah, you can kind of see it takes... Oh, that's weird. Something is happening here. Something is happening there with the raycast system. There's something a little weird happening, but that's okay. You know what I want to do? I want to substitute in the actual texture for this. Kind of sick of looking at that debug texture. New super performant method at the cost of significant disk space as well as a decent chunk of memory. Write a script that pre-renders every permutation of blocks you will place of visible cells and just save them to disk. Hey now. Hey now. No, I actually think the book Data-Oriented Design kind of it refocuses how one might want to think about level of detail, what is called lauding, like managing the level of detail. And traditionally, the thing you optimize for with level of detail is distance, but the author suggests that the actual important metric for level of detail is not distance to anything. It's like
maximum warp.
It's like the percentage. It's like the amount of perception that is exposed to the player. It's like how much focus does the player have on this thing? And I think that is that will work for us for this sort of thing. It's like, yeah, if this deck is occluded, if the player isn't looking at or can't see this deck, spend 0 time processing it. Just ignore it, right? Process it when it can be seen. And I think we have a lot of room in that area left to us. Thanks for the maximum no warp, no jewel. Hold on to your ads, people, over on Twitch. We're in an ad. We're in an ad right now. How are we doing on time? Pretty good. Pretty good. We got probably another hour here. You bring up an interesting point, Nanigans, too, with also something that's very, like, set theory-like, which is, like, there's a way of thinking of your component data as being set-based, where you're just, like, concerned about whether you have, like, how well represented something is in the set. And you can do a lot of stuff that way. You can think of your component data as just like that permutation of the set. There's some neat stuff you can do there when you're working with a database that works like that. Not for us, though. That's a little too big brain for us. All right, so draw task is great. I'm still concerned why the sculpting task created a flicker. It's probably because of the way I treat the preview block. It doesn't totally make sense. We're not going to worry about it right now, though, because that's not where the performance block is. I guess we can see how we're doing now. So now we got 100 something FPS. I add to this. Not much. I add to this. Still not much. No real change to process. Small change to physics process. I add this. Still a bit of a spike in physics process, but not much. Regular process is holding steady at 9 milliseconds. If I fill in this volume, which was causing us tons of problems before, let's fill in the whole thing for perfection's sake. All right, now we're a little rough in terms of process. We're going over. We've dipped under 60 FPS. So we are still paying for the drawing. But physics process is now holding steady. Relatively steady. It does seem to spike up, which I wonder what those spikes are caused by. It's probably has something to do with the sculpting system. We could actually probably find out. We start this. We start the profiler up. Probably see where these spikes are. It doesn't seem to be anything we're doing here. Oh, I messed up. So we're still, the rendering cost is still high, I think. I don't think we're having like a VSync thing. I think we're actually paying this. So I don't think we're VSyncing. The monitor makes me think that we're not VSyncing. We're making 6 draw calls for about 50,000 primitives, which is a little much. We utilize our GPU so little in this game. I'm so tempted to start doing more GPU stuff. I'm so tempted to do some GPU, some compute shader, and some other stuff. I don't really want to get in there, but I'm so tempted. Nanigans, yeah, in the web dev space, there's a pattern that you like to call. Oh, there's a pattern you like that is called idle until urgent. Basically, you just spawn a bunch of unimportant tasks. Oh, you pawn a bunch of unimportant tasks to whenever the processor has time to spare, until a time comes when the task actually becomes urgent, in which case you up it to the top of the queue and run it right away. Yeah, that's nice. Yeah, I like to, when I can, I like to just put a background thread, which I don't have that doesn't give me the flexibility to like go wide with like the worker thread pool, but I could probably dig into it more. We could probably go a little wider, but yeah, I think we need to. I think our CPU is busy, and I have a 7950 X3D, which is like a fairly high-end CPU. So my being CPU bound is a problem. My CPU is a beast, and we kind of want the first version of this game we have in mind is kind of more of a desktop companion style game, and that needs to have tiny performance. Little performance. It needs to be very performant. It needs to be like little thing that just kind of runs. So we have a ways to go on improving the rendering here. Clearly the best thing we can do is not draw something, so let's keep working to that end. One thing I should be doing, because we don't know what its impact is going to be like, is to just turn the cutaway system back on, which is not as simple as just turning the cutaway system back on. One does not simply just turn the cutaway system back on, and yet it's kind of what we need to do here. What I really need is the block flood filling system. I need this task. I need a continue with task, I guess. Or I could just run both these functions as one task. I also don't know if I don't think I need to attach this to parent anymore, because I don't think we have a parent block editor system group task, which maybe we should. Maybe we should have a block editor system group task, like a parent task. That's kind of why I wrote this. I think we used to do something like that. All right, what needs to change about the cutaway system? Part of the problem with the cutaway system is how it interacts with cursor coordinates. So we use the game.input.cursor coords. How is that set now? It's okay. By the time you finally ship, we'll be out of the hardware crisis and these specs will be obsolete. Yeah. Right. All right. Where do we go here from here? So we do set the cursor coords. The cursor coords now is this other thing. So it's the X, Y, Z, X, Y, Z in regular space, plus the W component, which is its face. If that matters at all. So what I need to do is any references to cursor coords. Well, here we've got an XYZ plus block, get coords. Oh. So we've got the exterior. We're not doing this room stuff anymore, really. Okay, so if we run this, what happens? I'm still not sure where we run this from. It's really not part of the editor system group, is the thing about it, though. It's really not. It's kind of it kind of belongs somewhere else. Although maybe it could be like mostly cached or stored. Maybe we can do something like kind of what Nanigans is suggesting. Because the cutaway thing is actually pretty stable. I just don't know where we execute this function. It needs to follow the block flood filling system. So if the sync task is completed, we can run this. Cutaways equals cutaway.bulk. Oh, this is so old. Do we have a newer cutaway system? I really hope we do. Or did I never rewrite this? I never rewrote it, huh? Okay, so this works on a totally different thing. It works on a cutaway enum, which is not what we use anymore. All right, so I got to rewrite this whole system. Cool. Cool, cool, cool. Tight, tight, tight. That's what we're doing now, I guess. You weren't being serious about saving every possible permutation. You'd exponentially use resources. No, I don't think of it that way. I'm thinking of it if our cutaway is compartment based, then the cutaways that we do is like a known quantity after edit time. So even if it's just like a bit mask or something that we can save that says, here's the cutaway profile if you're looking at the game at this camera angle for this given compartment. Where we can just do, yeah, exactly, Mr. Cat, a yummy, yummy bit mask. Exactly. I think something like that is an option, and I don't think that's a huge amount of performance or a huge amount of space. That might be a reasonable space trade-off. Anything that we can like bake in at edit time that remains valid over the course of runtime might be worth it. Might be worth it. Emphasis on might. Okay. So the cutaway is like, you see this room, all the foreground walls and ceilings have been erased, right? That's like, this is what we call a cutaway. And this is different than like the occlusion thing we were talking about, where like a block is occluded. Maybe I want something else. Maybe I want to call it like hidden. I'm still kind of tempted to specify a block as not being visible until some system is able to, until we have some kind of like raycast system that can get to the block and triggers it and says like, hey, this block is visible. I'm also tempted to do something like that. That would also be dependent on the cutaway though. So it would be like a block visibility system or something like that. You don't suggest recreating the library of Babel Babel Shipblocks edition? Yeah, I don't either. I don't either. Necessarily. I keep testing these worst case scenario performance because like I need to know. I need to know where our ceiling is and I need to know where the struggle is. It seems like we are still very CPU bound for rendering, so I'm really tempted to do some like compute shader shenanigans, but I'm also not convinced that that will be faster. It could be faster. There's a world where it's faster because we know all of the resources that we're going to draw. We generally know them all, and we would need to update that in the GPU very rarely. The biggest thing would be sending over the buffers, like the command buffers for like what to draw and where. I don't know if we could actually easily overcome that. I don't think it's worth it. Because our rendering is expensive, but it's still generally under our target, especially if we can find other gains. All right, I'm not thrilled about what I'm going to have to do for the cutaway system here. I don't know if I'm in exactly the headspace to rewrite this whole system. It would probably be easier than coming up with some kind of occlusion culling. Let's look at our list of block tags and see if... I think there's an opportunity to do something here with block tags. So we have a hole. Could be a hole. It could be a door. I don't know if we care about whether the block... I guess we do care about if the block is a door. The block is a room. I don't know what that means. Like, where are we using this? If block.tags.room, like, what the heck is this? xtags.has block.tags.room, block.hole.inner, block.hole.outer. This just tells us if a block is in a room. Who is setting this stuff? Nobody. This is something that the cutaway system might theoretically do. Right now, we don't do this. We don't do anything with this. about that. I'm perpetually torn between what needs to be handled at the resolution of an individual block and what needs to be handled at the resolution of a face. And it's arguable in a lot of these cases what you could do one way or the other. What did I say I wanted to do? I wanted to sub out the actual texture that we're going to use for this stuff, the hull texture. I feel like that's a good start. And just turn off this stupid debug texture thing. But yeah, this is so responsive compared to where we were this morning. So excellent start. I say this morning, I'm pretty sure I started streaming at like 11:58 or something like that. This is a huge improvement, so that's good. But yeah, let's get the correct, like, I feel like the line work looks really unclean using this texture. So, you know what I think is happening with that? I think hull type, for hull type 0 was defaulted to outside, but I think I've changed that. Yeah, so block.hull is either outer, middle, or inner. And I think we need to change that. I think I want it to be inner, middle, outer, but maybe not. That's how I'm storing the texture right now. Looks really fast. Yeah, we don't have that slowdown that we had. It's like, it's not quite 60 FPS, but it's close enough at the moment. Right now, I very lazily set up a global to store our... So I have default, then inner, then middle, then outer at the moment. And you just look up based on these. And the way I was thinking about that... Maybe we'll do this a little differently. I want a default value to be undefined, essentially, to like trigger the default block. So that you have to put in some work to get a correct value. So yeah, I guess let's just do it. Let's flip this around. This is going to be very broken for a second. There's a lot of uses of this. And I probably broke a lot of things. Or maybe I didn't. Maybe everything's just fine. Maybe everything just works. Crazy. All right. This should be less upsetting to the eye to look at. Feeling fine. There's something happening on a delay here. I think I'm noticing the CanvasItem drawing systems hang up. But I feel like almost nobody else is going to notice this. There's a little bit of flickering. That's unfortunate. What is going on with that? I think it's an outlining thing that I'm doing. It's viewable for a split second. It's not viewable all the time. It also seems to be happening not when I necessarily change tiles. Yeah, it's unfortunate. We can figure out how to get around that. Just got out of a meeting. What was the trick to improve the performance? It was actually the trick. The main trick was to just put the CanvasItem drawing system, which is the system that prepares the draw parameters, to just put that on a background thread. It was actually taking like 2 seconds to run. And that was the worst culprit in terms of the slowdown. It was just preparing all of the draw parameters. We're still pretty CPU bound on rendering, and it looks like we're using all 60 FPS just on rendering, which is kind of okay because that's honestly all we're using the Godot process for, like the regular process. So as long as we can keep our gameplay loop really tight. My only concern is that we're rendering this at like 60 FPS on like my 7950 X3D. So we definitely need to make further improvements. Crazy that flipping the numbers here for the whole enum just kind of worked. Block tags. Oh wait, block tags and block dot tags. Oh no, they're the same. Okay. Maybe we have a block tags dot draw or something, and like we have to affirm that we want this block to be drawn. And if we don't affirm that, it doesn't happen. I think opt-in is probably better than opt-out. I don't know. I haven't decided. You're gonna head out? No worries. Thanks, Nanigans. Take it easy. LSDev, is there any chance you can retain draw parameters and whatnot between frames, or at the very least some of them? We are. So, at least in terms of the canvas items themselves, which is the things that do the drawing, that's kind of one of the main advantages of using those is as long as the draw parameters don't change, as long as you don't cue a redraw explicitly on a canvas item, it actually just continues to draw itself, and it allegedly does so performantly if you don't change what needs to be drawn and you don't cue a redraw. It'll just, which is why it's pretty cheap to just, set a static image on a canvas item and move it around physically with the transform system. That's why that's the intended workflow. So we are doing that to an extent. Part of the reason why the canvas item drawing system is slow is because it is working out what the draw parameters should be, and it keeps track of the hash of the last draw parameters for that layer. And if they're the same, it doesn't push the draw, so it doesn't cue the redraw. So in theory, we're saving a lot on that. I say in theory, because there still seems to be some CPU cost for the rendering side. I don't know what it is, but there's some cost. If it really becomes an issue, you could take the CPP dive and make a GD extension. Yeah, I think for me, if it becomes bad, truly bad, given what we have, I think we probably go the shader route rather than trying to like futz with the render server or whatever. Personally for me, because like I can't write C++, but I actually do know a bit of shader languages. So for the same reason we're using C#, I think our fallback would be to do some more stuff directly in shaders, because I think we know enough about our situation where we could. You've dabbled a bit with GLSL4. Nice, Mr. Cat. It's a good skill. Everyone should learn a little bit about shaders. I think shaders are super intimidating when you first look at them, but once you understand like what a fragment shader does, it's like pretty straightforward. Is there any chance? Hashing tends to get rather expensive. Hashing every frame, even worse. You might be able to get away with a straight checksum rather than a sophisticated hash. Yeah, I don't know. Because it's not like we can just, if the number of draw params doesn't change, there still might be changes to the draw params. So I'm going to be super honest. I don't understand the difference between a checksum and a hash, but I think we're doing about the best we could do, which is we're using the high performance community toolkit, and we are passing a span to the high performance. I'm looking for the code. Yeah, so here we just combine the content of this list. We give it a span. We give it the span copy of the list, and it hashes them out. And so, yeah, the hashing for a CanvasItem drop param is pretty involved. It's like all of this. Could we maybe... We could maybe speed it up here. I'm not super concerned with this part just because we've put this system on a background thread and it's doing fine. But yeah, there's probably improvements we can make there. For now, it's performing its job, which is to minimize the amount of redrawing that we do. And I think we save enough on redrawing. I mean, maybe that's not true. We could just forget this part and see what happens. See what the performance profile of that is. It's a little slower. Not like noticeably slower. Versus if we do it like this. If this doesn't provide us a significant speed up, I'm like moderately concerned about what's happening under the hood, but let's try to check a similarly sized thing here. So this seems to be worse for some reason, but maybe the overall FPS is better, actually. It's not a perfect... This isn't a perfect test environment. Also, these lists are going to get smaller once we actually do occlusion culling, which should also help. So yeah, occlusion culling we really need to do. Some kind of occlusion culling. You know what we should do is we should have a block tag that's just like draw. And it's like opt-in. I don't understand what this room tag means. Like, does it just mean that it has a compartmental value? Same with this cut. Well, I know what the cutaway means. This is a flag, so we could say draw with 1, 4. So what if we introduce a tag here where we can tell a block just basically to not draw? And we could actually, the reason we don't do or don't draw could actually be a combination of a number of other things. It could be a combination of, are we explicitly cutting it away? Is it occluded? I'm waffling a bit on whether I would rather draw by default unless occluded, or rather I would occlude by default unless it explicitly says, do draw this. Do draw this thing. And then the other question is, do we spiral up from the thing we want to draw to see if there's anything obscuring it? Or do we spiral down from the top and only tag things that need to be drawn? If we do it that way, we have to reset this tag on every object every time. Or we might accidentally... I guess we do need to process each object or block. Unless we want to... I've kind of loaded all of these tags into a single component because I don't want to waste space. And we can store a number of flags here. Random Journey, when you rather debug something being drawn that shouldn't be or something not being drawn that should be? Yeah, exactly. That's the question, Rhiannon. That is the question. I think what we're going to do is we're going to do something similar to the way our input system works, where we spiral up from the back of the block space to see like where our raycast is going to hit. I think we're going to do the same thing per block to see if the block needs to be drawn or not. It would be much better to set this data per face. Like, actually, I don't know if I can say this per block. Like, I think I can tell whether a block has been cut. The whole entirety of the block has been cut. But it's a lot harder, for reasons that I've illustrated earlier, to tell if a whole block is being occluded. Because if we look at this 0th block here, if you're looking at the block level, well, it's not occluded unless these 3 blocks are in front of it, or these 3 blocks are in front of it, or this block is in front of it. And then you need to keep doing that check as you go up. So that's a lot. If we could at least figure it out per face, it would be better. It would be a lot better if I could answer this question on a per face basis. Because that's how we're drawing. We're not drawing per block, we're drawing per face. Does this provide any tricks in my thinking of how to handle this? So we could know that this face can be drawn by checking to see if there's a block here, an opaque block here, or if there's an opaque block here and here. Or not and here, so this is sufficient. Thing is, it's not quite that simple because there's another block that could be in the way. That would also impact it. So if both an XY or a Z block are in the way, that would also cause a problem. Yeah, I want a simple way to figure this out. This is going to take some thinking. And that's not... Thinking is not one of our strong points. Maybe the best thing to do starting out would be to just work on the cutaway system. Because I at least understand how the cutaway system is going to work. Because I've already written it once. Because, yeah, it definitely seems like we're being punished a lot for overdrawing. We have some occlusion culling happening at the CanvasItem draw system level. I don't know if it's working super well. Like, if we go down to the auto tiler, the auto tiler logic here, that doesn't really do anything except, okay, so that just changes the ordering. So that auto tiler doesn't do anything for this purpose. It's really down to this get canvas item draw params function, which does a simple check. It does a simple elimination check based on the tiles that we've collected. There's another thing that I don't understand that might help us, which is we can actually process these drawable things in any order. We can process it as an unordered set. Right now we handle our blocks as a spatially stored buffer of things. Like we store it by its coordinate, so we don't have to store the coordinate. We store it, its index is the coordinate in 3D space, right? That's not unusual. But I'm almost tempted to operate on this on a different level where we think of it in terms of like tiles, like things to draw. And we think about tiles very differently than we think about blocks. Like maybe we do some early processing and the block tells us, we already kind of do this with our set block hull types. This is where we go through and we do an initial check with our blocks. We go through our blocks and we see like, is there even a hull here? If not, forget about it. If there is, let's figure out what faces there are. And so like here we'll add a hull, we'll add a tile hull to block position at the block face.x or whatever. And we'll do that unless, you know, there's nothing here. And then we eliminate these in a future point. So maybe we need to do this a little differently. A tile seems like a very small thing to be storing and processing, though. Especially when you think about things like camera rotation, where we can like bring a different view into position. This coffee is, I like almost took a drink of my coffee and I can look at it and tell you that it's like that disgustingly cold. I mean, it's not cold like iced coffee. I like iced coffee. We'll have some water. Some water instead. Appreciate everyone hanging out today. We made good gains today. I know we're kind of like in an analysis paralysis hole right now. But we'll find a way forward. The only question is which way forward. Like, we'll find a way forward for sure. I think Nanigans has some good ideas. Hope everyone's having a good day, though. I hope this is a nice place to hang out. Co-work if you're co-working. Chill if you're chilling. Marticus, you fucking love iced coffee. Yeah. I like cold brew. Cold brew is a little dangerous, but that's my preference. As opposed to, you know, traditional iced coffee, which is, you know, coffee that was brewed hot and then either allowed to reach room temperature or iced down. But cold brew, that is something else. That's like, My problem is where I live, it's the right weather for cold brew like 3 times a year. There's like maybe 2 or 3 weeks total in the year where it's like the right weather for cold brew. Nanigans always has good ideas. Yeah. Nanigans is doing a lot of what we're doing, but in 3D. And like, so some of the concepts don't carry over, but some of the concepts do carry over. I have this feeling that our rendering should actually be really stable, like our rendering performance. Unless we have like a ship where like not millions, but you know, where a ton of things are running around and like, unless we have a bunch of moving actors, I feel like the environment rendering should actually be really stable and like not that expensive. And I want to get there. This is good for the most part. But like right now we're paying for overdraw, I think, because we're trying to render a bunch of tiles that are inside this block. I think there's an outline trick. I think there's an outline little bit of cheating I'm doing that the CanvasItem draw params thing is like making really noticeable. I might have to update some of the auto tiling rules to get rid of that. But yeah, the first thing we need to do is we need to be able to see into... Yeah, we need to make this faster. We need to be able to see into this block. We also need to only be rendering the outer surface. So I do think doing some kind of check. I think working our way down from the max bounds. It's almost like doing a bunch of raycasting in parallel along each of these lines to see what can be seen and what can't be seen. I think you would alternate. You'd alternate between like the center block and then the 3 neighbor blocks and then the center block and then the 3 neighbor blocks and then the center block. And you would do something. You would do some kind of simple opacity check, some kind of thing, some kind of check of like, is there a face here? Does that face totally block everything underneath it? Okay, if so, just stop. The thing that doesn't work for me about that is how I would need to have some... I would need to store this separately. I would need to store this in a thing that would just be used for the CanvasItem drawing params thing. Like it wouldn't be something that's like on the block data. It's always a question of where you want your trade-off to be. Space storage or compute, right? And for every problem, there's a different answer. And I'm just thinking about, for this problem, what the good answer is. I don't love what's happening here with these corner pieces. It's probably really hard to see, but they're being drawn very briefly when I move the block. Very weird. There are some side effects to running this params thing on a background thread, and I'm seeing them. I'm seeing the side effects. But overall, this is well within what I would consider my tolerance for this stuff. Is this with the occlusion? No. What we've done is we put another process on a background thread, which is buying us all the time we need to be responsive. It's the process that like actually prepares the drawing parameters. Yeah, it helped a lot. It was the blocker in terms of having it be like properly responsive. It's not sufficient by itself though. We've got to do some other stuff. We've got to do the occlusion culling. For sure. We also need to get the cutaway system back on. What I probably should do is start with the cutaway system. Because I kind of know how that works. And that works a little differently than the occlusion culling. So is there something we could do here? Like bitwise or something that would be acceptable? Like, so we've got our like 0 with block. And we look at these 3 neighbors that might be in the way. We have these 3 neighbors as well that are opposites. There's something that's happening here with the fact that the face is really kind of bisected. Like we're kind of bisecting the face like this. Like a block in front will bisect this half of the face, and a block up here would bisect this half of the face, and it's true for all of the faces. It's actually more like 6 things. Like there's like 6 tile faces here. There's like there's 3 faces, but each face has a half a face. So maybe what we should do is we should store something per block that tells us which face halves are like obscured or not. Something like that. We could do that with 6 bits. We could probably store something else. Probably do a couple other things. We could probably have a bit for whether this thing is fully covering its block space. And we could probably have another bit for whether it's transparent. So maybe there's something we could store in a byte that would like tell us a little bit more about the rendering reality for this block. So we could do some calculations per block, and we could eliminate it based on other blocks. What's gonna mess me up is when we start talking about characters and stuff which don't have that multifaceted build. Characters that are just these little 2D cardboard cutout like things. It's gonna complicate things a little bit. Oh well, I think we had a good stream today. I know we kind of front-loaded all our productivity into that first part where we actually unlocked the performance there a little bit. And we kind of got to decide what we're going to do differently. It's probably going to be a wall clock time thing. Hey, Daniel Pancake. Thanks for the hydrate. Cheers. Gains. Yeah, we made gains. We made gains. You know, and that's all you can do. We're lucky that we could see the gains today. Sometimes you're making gains and you don't even see them, right?
Maximum warp.
You don't see them until someone comes in and was like, wow, I was watching this a month ago. Look at all this stuff that you got now. It's like, it's hard to see it when you're this close to it. But yeah, we had some gains today. Maximum warp, NanoDev. Hey, NanoDev, it's good to see you. Maximum warp. But yeah, this is Wednesday, so we're not even at the middle of our... Actually, we are kind of at the middle of our streaming week. I'm not going to be able to stream Saturday. But that's all right. We still got 2 days. We're only at the halfway point here. We got Thursday and Friday. So, while we've essentially run out of time today, we've got 2 more days this week to work on this. I think we'll be in a good spot. I think we'll be in a good enough spot where we can be like, rendering performance is acceptable. Let's move on to some other things. I think we'll be able to get there in a few more days. And then we can work on something else. Like finishing our block editor tool. I know we keep getting distracted, but you know, fundamental rendering performance, I think, is an important thing to keep an eye on. But yeah, I appreciate everyone watching in today here. Is there someone we can raid out to? We actually have a decent number of people in here today. I usually don't even bother with a raid. So we're a small streamer. See what we got going on today. Let's check the team. Who's in the team? But yeah, I appreciate you all. I especially appreciate all of you lurkers over on YouTube. Although there were a lot of people talking on YouTube. That was nice too. But I appreciate you all. You don't have to you don't have to say anything. You don't have to make yourself known. I see you. Hypnotic? Yeah. Hypnotic is one I'm considering for sure. Hypnotic's on my team. I think it's usually nicer to raid in smaller streamers. They're using Unity. Disqualified. This person's stream is starting soon, but they're playing Dark Souls. Yeah, it's probably Otter Make Games or Hypnotic. Otter Make Games is doing some cute stuff. Otter's been going for 5 hours. Hypnotic's only been going for a few. All right, yeah, let's go hang out with Hypnotic. Oh, everyone left. Maybe we don't raid out. We have a Raid Master channel redeem if people have a strong opinion about where we raid out to. But it looks like everyone left already. So maybe I'll let everyone just kind of scatter to their own preferred streamers. I took too long. On Twitch, you can't announce that you're wrapping up the stream too quickly. Everyone just leaves before we have a chance to raid anyone.
Maximum warp.
But yeah, thank you all. I gotta be more decisive. I gotta be more decisive in the future. I gotta be like, the stream's over. I've queued up the raid. Let's go. That's my fault. It's my fault. I'm not used to raiding out. Oh, now it says everyone's back. I don't know. I don't know what's going on. Oh, you just got here. You brought everyone. I see. We're wrapping up. See you later, Smooth, in a second. We're done for today. We'll be back tomorrow. I gotta go do my laundry and get back to work. But yeah, thank you all so much for watching. I hope you have a great rest of your day, and I will see you all next time. Bye.